Let's talk about Liquid 1353 max number of events can be attended. Give us two-dimensional array events, and for every element, it has a start date and end date, which represent event. You can attend an event which has a d greater equal to start date and a smaller equal to end date. And you can only attend one event at a day. So return the maximum number of events you can attend. So let's look at the example 1, 2, 3, 1, 2, 2, 3, 3, 4. So for the first day, we enter event 1, and second day we attend event 2, and the third day, day 3, we enter the event is the third event. So maximum we can return 3. So what we think about this question is that we should find for a specific date, right? We should go through those dates, find a specific date, the available event we can attend. So what does the available event we can attend mean? Is that for any events we have an end date smaller than this date, we should move out, right? And for this day, if there is any event with the start time is greater equal to this day, we should add to our data structure, some kind of data collections, right? And so, for example, if we have at a day D, we have multiple events we can attend. So what kind of event we should attend? We we should attend those events which end earlier, right? So there are multiple days of multiple events, right? So if even this is long, but we haven't attended this, it's still in our data structure, right? But because this will end earlier, and if we do not attend in the future, we are not able to attend this if even there are empty space, right? But for this empty space, apparently we can use this date for some date which end later. So apparently, for this day, we should save for those dates which end earlier, right? So for those dates available, we should have some data structure which can sort dynamically for the available events which end earlier. So we intuitively we are thinking about is use a priority queue or heap, right? So for the event, which for a specific date, which will add to our data collection, we should do some pre-processing. For example, we can have a bucket put for every day. What is the start for those kind of start date event for this day, right? So that we can iterate that day for this kind of range, trying to see for every day for this range, right? 10 to the power 5 range, trying to see what kind of events it is available and add to our priority queue. And then we also need to pull out every event which is end before this day. And then what to do is that we just select from this priority queue, find the event which is end the earliest and add to result add to 1, right? And pull this event out. So that will be the process. To optimize our solution, right? We can we are thinking about iterated day from the to the end date day by day, right? But we can use a maximal when we do the bucket sorting the event to some buckets. And also for our priority queue, we don't need to put events into it, right? What we care about is just the end date. So we can just use an integer to store the end date of the event. So there are two optimizations here. One is we use a max day. And another is our priority queue. We're not going to put in event anymore. We just put it in end time. So let's write code for this. For every event, we are going to have that has max equals max max event one, and we are going to have a bucket. So for our bucket, right, we also just need to store the in the in date, right? And for the bucket index will be the start date. So we're going to have mm, new list max plus one, right? Actually, this bucket we don't even need to be max, right? Because max is the end date. We just, for example, we have max m equals max dot max m event 0, right? So bucket can even to be smaller than to just we are based on the start time, right? But to get code simple, we can still use max, right? Um, let's use another variable, right? Then we're going to have arrays set all bucket. So I'm going to have k goes to new array list. Then we pre-processing to add the end date for each the to the related bucket, I'll say, for every events, right? So we're going to have bucket event 0 are going to add event 1. As we talk about, we just need to have the end date here. Then we're going to have int result equals 0, right? And priority queue. So we'll say for those available events, we don't care about its as long as it is still in our data structure. We don't care about its start date. What we care is its end time, right? So we want to join the event which end early. So we just need to have end time. Just instead of have array, we just have an integer. And for int I equals 0, I smaller than max, smaller equal to max, I plus plus. Then what we do is that so we'll first get rid of the events which have the end date is smaller than current day I, right? And mean keep dot peak is smaller than I. Then we'll pull out. Then we'll add those available events we can attend. So what we do is for every end in buckets, right, we're going to have main keep offer this end. So we'll say if this mean current data structure is not empty, then we can attend at least one event, and we are going to choose the one which end earliest, right? So, and then remove this event from our main heap. in the end, just return result. The things that so the problem is that this will be actually we want to so if we have actual m here, right? So so we'll add some kind of if statement that if this I is smaller than, so this will get I smaller than m, right? Small equal to m. So let's just get rid of this condition. I think it will not save too much time. So that it will not be auto in bound. Okay. The time complexity. Let's look at the time complexity. This will be n events. So this is actually an ON operation, right? Because this is linear, put that into buckets. And that is, there is a priority queue, right? This priority queue can be an event. And this is, for example, the max is D, right? So this will be D log n time complexity. And this is O n, right? And the space, this is linear. This is also linear. Let's also write a Python code for this. So we're going to have max and max max and m equals max. So I'll say and for underscore and in events. Okay. So we're going to have groups equals a bucket for underscore in range max plus one, right? Then for start and in event, we're going to have groups start at 10 end. So we're going to have min heap and result, right? Min heap. So this one for day in range. So m plus one, right? Then we'll say while min heap is not empty and min heap 0 is smaller than day for those days, which should remove out, right? We should have heap q dot heap pop min heap. Then we need to add those state, which is should add to our data structure for and in groups state, right? We're going to have heap q dot heap push min heap and so so let's say if this min heap is not empty, then we're trying to see heap q dot heap pop min heap, and we're going to have result which should add equal to one, right? So in the end, just return result.